This video is on the coordinate plane and intercepts. On the screen, you see a coordinate plane. The coordinate plane consists of two axes. Your x-axis runs left and right horizontally, and your y-axis runs up and down vertically. Where they cross is called the origin. O-R-I-G. I shouldn't have tried to spell it. Origin. This is where your graph originates, right here at the origin. The x-axis and the y-axis are number lines. So from the origin, which is 0, as you go to the right, the numbers get bigger. Usually the boxes are worth 1. So 1, 2, 3, 4, 5, 6, going that way. And up 1, 2, 3, 4, 5, 6, and it continues to go up. Everything in this upper right box here are positive numbers. But if you go down or to the left, you have negative numbers. To the left of 0 on the number line is -1, -2, -3, -4, and so on. And below 0 on this number line, kind of like an old-timey thermometer up and down, but this goes -1, -2, -3, -4, and so on negative. These are number lines. Up and to the right are positive, down and to the left are negative. Your quadrants, which are normally given with Roman numerals, your quadrants are quadrant 1, that's Roman numeral 1, quadrant 2, that's Roman numeral 2, quadrant 3, that's Roman numeral 3, and quadrant 4, that's Roman numeral 4. When you're plotting coordinates, it is always listed as x, comma, y. So if you were told to plot 2, comma 1, you know that 2 is your x and 1 is your y. So if I want to go x, comma y, 2, comma 1, I start at my origin, which is 0, comma 0, and I go 2 places to the right to get to 2 on my x-axis and 1 place up to get to 1 on my y-axis. So if we were plotting A, 2, comma 1, there's where it goes. Example B, if I were plotting -3, comma, -1, then I start at the origin. The first number is your x number, so 1, 2, 3 places to the left. Second number is your y number, so 1 place down. And here would be point B, -3, comma, -1. And one more example, -4, comma, 0. If I want to do -4, comma, 0, -4, and then I don't go up or down, it's a 0, and there is point C. If it asked you where point A was, your answer would be, it's in quadrant 1. If it asked you where point B was, your answer would be, it's in quadrant 3. And if it asked you where point C was, your answer would be, it is on the x-axis. It could also have been on the y-axis or at the origin. 0, comma 0 would be right here at the origin. Everything in the first quadrant has positive x and y values. Everything in the third quadrant has negative x and y values. And they're mixed up on quadrant 2 and 3. Quadrant 2 is negative on the x, positive on the y. And quadrant 4 is positive on the x, negative on the y. Again, all coordinates are listed as x, comma, y. So let me do one more example. 0, comma, 5. 0, 5, 0 left to right, so I stay at the origin, and then I go up 5 places. And there is point D. Where is D? It is on the y-axis. Let's look at the map grid. The difference between this and the one I just showed you, had 4 quadrants. This one just has 1 quadrant, so everything is positive. On this particular one, the rows have a number to the left, 1 through 5. The columns have letter names A through E going left to right. And every place on the map is in a single row and column. So this says, which building is in square A3? A3 would be right here. That is the school. Where's the house named the square? The house is right here. That would be A1. Which buildings are in column D? I see a post office, and I see a police station in column D. Here's a coordinate plane. Your x-axis going left to right, and your y-axis going up and down. Remember, up and to the right are positive, down and to the left are negative. And that is told here. Here's your origin in the middle. Positive values on the x go to the right. Negative values on the x go to the left. It's a number line. Positive values go up on the y-axis, and negative values go down on the y-axis. It's a number line. Here are your quadrants, 1, 2, 3, 4. They go counterclockwise. To plot points or coordinates in the plane, you will have 2 directions to move. Each coordinate has an x value and a y value. It's always written x, y. When plotting, you will travel across the x-axis first and the y-axis second. You may also think of traveling left to right first, followed by up or down. The number of units you travel would depend on your coordinate. If your coordinate is 3, 1, you would go 1, 2, 3 units to the right, 1 unit up, and your dot would go right here in quadrant 1. So let's look at some practice problems. On a coordinate plane, find the correct location of the following quadrant 5, 4. So I start at the origin. That's going to be 5 places to the right and 4 places up. It should be right here, 5, 4. Negative 3, 7. I instantly know that is quadrant 2. Negative 3, 7, right here, quadrant 2. Negative 2, negative 3, quadrant 3. 1, 8, quadrant 1. 6, 0, x-axis. 0, negative 3, y-axis. The next thing I'll talk about are intercepts. Intercepts are where lines cross or intercept the axes. I have graphed 3 lines on this coordinate plane. Number 1 right here. If I was asked to find my intercepts, the x-intercept is 2. It crosses the x-axis right here at 2. Or I could say at 2, 0. And my y-intercept is negative 3. It crosses the y-axis right here at negative 3. Or I could say 0, negative 3. Now, these boxes could be worth 2 each or 5 each or 10 each. It just depends on how I labeled them. I labeled every other box 2, 4, even numbers. So that means all my boxes are worth 1. The simpler ones, all the boxes will be worth 1. But always look, your boxes could be worth more than ones. For instance, if these boxes were worth 10 each, then this intercept would be 20 and this one would be negative 30. Let's look at line 2. Here's line 2. Think in your head, what is the x-intercept? We have to find the origin. The origin is right here where the two axes meet. My x-intercept is right here. It is negative 1. The coordinate for that is negative 1 comma 0. What is the y-intercept for line 2? The y-intercept right here is positive 1. The coordinate is 0 comma 1. And let's look at one more. Here's line 3, my downward slope line. What is the x-intercept and y-intercept? The x-intercept for line 3 right here is 1. It crosses the x-axis at 1. The coordinate for that is 1 comma 0. What is the y-intercept for line 3? The y-intercept right here is 4. 1, 2, 3, 4. It intercepts the y-axis right here at 4, or 0 comma 4. Let's look at a few more examples. What are the intercepts for number 5? Number 5 intercepts the x-axis right here at negative 5. It intercepts the y-axis right here at positive 2. And it lists out those coordinates for you there if you need them. Notice that anytime you have an intercept, one of your two values will be 0. If you have an x-intercept, your y value will always be 0. When you have a y-intercept, your x value will always be 0. What are the intercepts for number 6? Number 6 intercepts the x-axis at negative 2. It intercepts the y-axis at positive 3. Notice that the coordinates for any intercept always contains a 0. If your x-intercept is negative 2, then the value is, the xy coordinate is negative 2 comma 0. I have a y-intercept of 3, and my coordinate is 0 comma 3. Here's another one. Your x-intercept's negative 3. Your y-intercept's negative 2. Let's look at one where the answer is not given. Look at number 10. What is your x-intercept and what is your y-intercept? Your x-intercept is 1. The coordinate is 1 comma 0. What is your y-intercept? Your y-intercept is 1. Your coordinate is 0 comma 1. Look at number 12. What is your y-intercept for number 12? Your y-intercept is 1, 2, 3. Your coordinate is 0 comma 3. Your intercept is just 3. What do you think the x-intercept is? This line intercepts the x-axis right here at what looks to be exactly 1.5 or 1.5. So the x-intercept, we would say, is 1.5 or 1.5. The coordinate would be 1.5 comma 0. What are the intercepts for number 10? We have to count from the origin. The numbers are not given. So I count 1, 2, 3, 4, 5, 6 boxes to the right. Your x-intercept is 6. What do you think your y-intercept is? Your y-intercept is negative 1, 2, 3, 4, 5, 6. Negative 6. This helped you a little bit. If you started here, you know this y value is negative 4, so you could have counted from here, negative 5, negative 6. Here, our y-intercept is 5. Our x-intercept is 1, 2, 3, 4, 5. I know this value is 4 on the x, so I could have counted one more. And let's look at one more. What do you think the x and the y-intercept are for number 12? The x-intercept looks like it's negative 2.5 to me. What about the y-intercept? The y-intercept is negative 3, negative 4, negative 5. Your y-intercept is negative 5. Here we have an equation, x equals 2y. We can graph a line for that equation. There are many ways to graph it. I want to first talk about how to graph it using a table. Even though I'm not going to have you graph them using the tables, you need a general idea of how it works before we move on. So if I wanted to graph this using a table, I would make up some values for y and plug them in and see what values of x I get. For instance, if I plug a 0 right here for y, 2 times 0 is 0, so I would get 0 for x. If I plug a 1 in for y, 2 times 1 is 1, I get 2 for x. And if I had a 2 for y, 2 times 2 is 4, I would get 4 for x. Then I would have 3 sets of xy coordinates, and I would put those on a coordinate plane. Now, your table where you plug them in would not have to be this detailed, but here's what I just did in my head real quick. Plug 0 in for y, got 0 for x, there's my coordinate, 0, 0. Plugged 1 in for y, got 2 for x. So here's my coordinate, x, y. Plug 2 in for y, I got 4 for x. So here's my coordinate. 4 is my x value, 2 is my y value. And then I would just plot those 3 points on a line, and I have graphed that line using a table. Let me show you another one. I can graph this equation by plugging in 3 values for x and getting 3 values for y. Surely you can do it in your head pretty quickly. If you plug 0 here, you get 4 for y. If you plug 1 in here, you'd get 6 for y. If you plug 2 in here, you'd get 8 for y. If you can't do it in your head that quickly, you could do some sort of table like this where you plug 0, 1, and 2 in for x, see what numbers you get for y, and rewrite your coordinates. And then we could plot our coordinates on a coordinate plane. Here is 0, 4, 1, 6, 2, 8. So I was able to graph that line from these coordinates I just found. My x-intercept is -2. My y-intercept is +4. Here's one more example real quick. Here's my elaborate table, but I could have just come over here and did one like this. I could have just said, okay, if I plug 0 in for y, I get 5 times 0, 0 plus 5 is 5. I get 5 for x. If I plug 1 in for y, I get 5 plus 5 is 10. And if I plug 2 in for y, I get 15. And that's what I did here. I just showed more work. But here are my coordinates, 5, 0, 10, 1, 15, 2. Here are those coordinates graphed. 5, 0, 10, 1, 15, 2. My x-intercept is 5, and my y-intercept is -1. Notice on my table that if I want to know what my x-intercept is, I find the 0 value for y. There's my x-intercept, 5. Anytime you're looking for intercepts, if you look for the x-intercept, your y value is 0. If you look for the y-intercept, your x value is 0. Again, I'm going to teach you a different, more popular way to graph, but you need a general idea how these tables work. So here's the table, and it is telling you to plug in these 5 numbers for x into this equation and see what numbers for y you get. Now, you may or may not can do these really quick in your head. If you plug -3 in for x, you get -9 plus -4 is -13. If I plug -2 in, I get -6 and -4, which is -10. If I plug 0 in, I get 0 minus 4 is -4, and so on. So here are the answers. Again, if you want to find an intercept, find the 0. Here is a 0 value for x. That means your y-intercept is -4. So when it graphs it, you know the line is going to cross the y-axis at -4 because we found that 0 value. It's hard to see, but they have plotted these 5 points on the graph, and we can enlarge it a little bit. And the y-intercept is going to cross right here at -4. It didn't show us a line. All right, here we could plug these in real quick. If you plug in -2, you get 5. Plug in 0, you get 7. Plug in 3, you get 10. Plug in 5, you get 12. If you plot those points, here they are. And if you imagine a line being drawn through those, it would cross the y-axis right here at 7. And I knew that because I found the 0 and my y-intercept was 7. In order to do this, we need to know a little bit about slope, and I haven't gotten to that yet, so let's skip this one. I'll talk about one more with you. Here we have an equation, y equals 2x. There are many different ways to graph it. Let's graph one more using the table. So not as elaborate as the ones I had done before, but let's pretend that I plug in negative, I'm going to plug in a bunch of -3. Here I would get 6. -2, I'd get -6. -2, I'd get -4. -1, I would get -2. 0, I would get 0. If I plug 1 in, I get 2. 2 in, I get 4. 3 in, I get 6. I wanted to do several so you could see both intercepts. So we have a coordinate plane here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. 1, 2, 3, 4, -5. Put another number here. There's 3. Kind of help us know where we are. And if I plotted these 3, -3, comma -6, -2, comma -4, -1, comma -2, 0, comma 0, 1, comma 2, 2, comma 4, 3, comma 6. Notice how I've got a nice straight line, and that's because all the equations we have done are linear equations. Linear equations always have exponents of 1. If I put an exponent of 2 right here, that changes everything, and I would have a parabola. And if I put a 3 right here, I'd have a hyperbola. But those are a lesson for another day. Everything we do, because we have exponents of 1, are linear, meaning straight line, one-line equations. If I want to find the intercepts, I find the zeros. Here's my zeros. I have a 0 for x here. That means my y-intercept is whatever's here, and it's 0. And I found the y0 to find the x-intercept of 0. The intercept was the origin, so both of them are the same. So that wasn't a very good example for that. But if I had, for instance, a line that crossed, let's cross it right here. If I had a line that crossed right here and here, well, that table, that value, x comma y here is 0 comma 2. It goes across right here at -1 comma 1 and -2 comma 0. So if this were my table, I could find the intercepts. My y-intercept is 2 and my x-intercept is -2. I found the zeros to find my intercepts. I can also look on the graph to find my intercepts. The x-intercept is -2. 0, 2, 0, 2. My y-intercept is +2. My x-intercept is -2. You can find the zeros, or you can see where they cross the graph. So a quick review of our coordinates. Number 1, 3, 1. Where is 3, 1 found? What quadrant or what axis? The answer, 3, 1, is quadrant 1. So you could put Q1, or you could put a Roman numeral 1. Either one of those ways to write it. Think about number 2, -2, 4. Where is that found? -2, 4 is in quadrant 2. -3, 0, where is that found? -3, 0 is found on the x-axis. Try -1, 0. Think about it. -1, 0 is on the x-axis. Number 5, 3, where is that found? 5, 3, quadrant 1. Let's do some more real quick. 0, -5, where's that found? 0 left or right, -5 on my y value, that is on the y-axis. 4, -4, where's that found? You don't even have to pinpoint the spot. You just know right and down is going to be somewhere here in quadrant 4. 0, 0, where's that found? That is your origin. I think it's spelled O-R-I-G-I-N. And then let's pretend that we had all these dots and we graphed it. And it said, where is the x-axis? And your answer would be, I'm sorry, not x-axis, x-intercept. Where is the x-intercept? The x-intercept is right here, -1, or -1, 0, it may be stated. And what is the y-intercept? The y-intercept is +2. That is your video on coordinates and intercepts. Thank you.